part 3 of exam 1 key. We're on number 9 right now. So in this problem, you are given a table and you are asked to fill in all the gaps in that table. So let's look here. We're given a row for symbols, number of protons, number of neutrons, number of electrons, and then finally the mass number. So here we're given this symbol for ruthenium. Not really necessary that we know what the name is, but that is ruthenium. And we need to know the number of protons. The easy way to figure out the number of protons is just to go on the periodic table, which you were given in the exam. So here is ruthenium. Its number on the periodic table is 44, so it has 44 protons. All right, the neutral atom, which we're told these are in the table. A neutral atom will have the same number of protons and electrons. Great. All right, now to find the number of neutrons, we have to take our mass number, which is given here, so we can just write that down. Mass number 101. All right, so there's our mass number. To find the number of neutrons, we just take our mass number on our little calculator here. 101 minus 44. 57. You can probably do that in your head. Let's fill that out. All right, whatever remains that's not protons in the mass number is neutrons. All right, so let's look at this guy here. We're given the mass number of something. We're given the neutrons of something. Well, to find protons, we just take our mass number, 210, subtract our number of neutrons, 126, and that tells us the number of protons, 84. It's a neutral atom, so the number of electrons will be 84. Now on to identifying this bad boy. Now, I think a lot of people kind of wigged out about this one because the mass number is 210 and the number of the number of protons was 84. And so a lot of people, when they were looking at the periodic table, went, oh man, the average, atomic mass that's given here is 210 for astatine, but there's 84 protons in polonium. So what do I choose? The answer is you always, always, always go with the number of protons. Because in this case, even though, remember that these are weighted averages, so this could be an isotope of polonium, and in fact it is. Okay, so when you're trying to determine the identity of something, don't look at these mass numbers. Look at the number of protons. We've got 84 in polonium, so our symbol, not 84, 210, polonium. All right, 1 point for each of those guys. All right. Moving on to the next one, number 10. We have got a newly discovered element named bentonium, and it has 3 naturally occurring isotopes. So we need to use the mass of each isotope and the abundances given to calculate the average atomic mass of bentonium. All right, so what I'm going to do is find the weighted average. I'm going to take the mass in AMU and multiply it by the decimal of the abundance, and that should give me my answer. So let's start with this isotope. These are my initials, incidentally, LAB. Maybe my parents wanted me to be a scientist from the beginning. I don't know why else they would give me those initials. In any case, 642.25 AMU times, that's my mass, times the abundance of that particular isotope, 0.67, plus 638.34 times the abundance percentage, 0.22, plus 632.19 times 0.11. And when I calculate that out, I should get 640.28 AMU. Now, if you said 640.28 AMU, you should have gotten full credit, assuming that you showed all your work. Now, in some cases, because I told the TAs that our standard that we talked about in class was 1 decimal point, I know that a couple people at least got a point taken off if they wrote this. I will accept either answer. Either one is actually fine. So if you see that you got a point taken off for writing this, you can potentially do a regrade and get a point back. So just be aware of that. If you wrote, instead of AMU, grams per mole, that is actually incorrect, because we're dealing in AMU right now. All right, moving on. All right, number 11. So we've got acetyl-CoA, a vital enzyme for the Krebs cycle. Its chemical formula is given below. We need to know what the molar mass is of A-CoA, and we're asked to show our work here. Okay, so what I'm going to do is I'm going to have to find out the masses of each of these individual atoms that are part of that overall molecule, add them together, and that should give me my molar mass. So I have 23 carbons, each of them are 12 grams per mole, plus 38 hydrogens, each of them are 1 gram per mole. Now incidentally, if you used 2 or 3 decimal places to calculate the molar mass, you're going to get a slightly different number than I'm going to get just using 1 decimal place, and that's okay. As long as you showed your work, you should have gotten credit for it. I think I might have circled it if it was like slightly off of what I get, but that's okay. All right, 7 times 14 grams per mole plus 17 times 16 grams per mole plus, now we're at phosphorus, so 3 times 31 grams per mole plus 1 little sulfur. I'm not going to put 1 even though this is 1 times 32.1 grams per mole. All right, after all of that, I should get 809.1 grams per mole. Oh my gosh, and somebody else is calling me. We cannot catch a break. Part 4 coming up in just a second.